Okay, we are moving on to section 13.2. There's a lot of information in section 13.2. A couple of things we'll cover here is how do you define and draw general angles, and we'll learn what is a radian measure. Okay, and we may get into some arc lengths and areas of sectors if we have time. Okay, so let's start with drawing angles. So I have an x and y axis, and we can draw angles of any measure on an x and y axis. So if you think of the x-axis here as 0 degrees, if you go all the way up to the y-axis here, that's 90 degrees, down to 180, 270, and if I go all the way around, it's 360. Okay, so a couple vocabulary terms. This is the initial side of the angle, this is the vertex of the angle, and where the angle ends is the terminal side. Okay, and an angle is positive if we rotate counterclockwise, which would be this way, and negative if we rotate clockwise. Okay, so how do I draw an angle of 75 degrees? Well, I just draw my XY axis. Which quadrant? Remember quadrant, this is quadrant 1, 2, 3, and 4. Which quadrant is 75 degrees in? It's in this first quadrant, it's less than 90, so all I have to do is draw this angle here. And there's my 75 degree angle. Okay, if I'm going to draw a 240 degree angle, I need to go past 180, but not quite to 270, 30 degrees less. So this would be 240 degrees. Okay, 500 degrees. Now I'm going all the way around the circle once, and what's left over? I got 360 plus another 140. So it's going to look like this. You're going to draw all the way around and then back to here. And that's going to be your angle, 500 degrees. Negative 150, we would rotate clockwise down this way, and it'd be a little bit less than 180 there, so it'd be right there. So that's how we draw those angles. Okay, another term here, coterminal angles. It's the same term, it has the same terminal side, and we find coterminal angles by adding or subtracting multiples of 360 degrees. Okay, so if I have an angle at 65 degrees, that angle is going to be right here somewhere. What angle would I get that's exactly the same as 65? So I can add 360, and that would be 425. So this angle would be coterminal because it ends in the same place. It goes around the circle one extra time. So that would be 425, or I can subtract 360. So I would get negative 295 there. So that would be this angle from going backwards. That would be negative 295. So those are coterminal angles. We just add or subtract 360. We can find numerous coterminal angles by continuously adding or subtracting 360 as many times as we want to find coterminal angles. Okay. All right, let's move on to radian measure. Okay, what I have drawn here is a unit circle. Okay, a unit circle is a circle with a radius of 1. Okay, a radian is the distance around a unit circle. So remember, if the radius is 1 here, what's the distance around a circle that's 1? Well, distance relates to circumference, because circumference is distance around a circle. The circumference of a circle is 2 pi r, 2 pi times the radius. Okay, well, if the radius is 1, the circumference of this circle would be 2 pi times 1, or just 2 pi. So 2 pi is equivalent to 360 degrees. And pi is equivalent to 180 degrees. So we can find any degree measure using the ratio that pi over 180 is equivalent to radians over degrees. Okay, so it's proportional throughout the circle. So for example, let's just pick an angle like 90 degrees. If pi is 180 degrees, what would 90 degrees be? Well, 90 is half of 180, so it would be 1/2 of pi. Now, normally they write it like this. They write it as pi over 2, which is the same as 1/2 pi. So that's what 90 degrees would be. 45 degrees is pi over 4. It's 1/4 of pi. So that's just the way we convert these and how radians and degrees relate. Okay, so let's do an example. Let's convert. Let's go 125 degrees into radians. So going back to this, if I was to convert to radians and I wanted to solve for radians here and I multiply both sides by degrees, I would get this formula here. So to convert from degrees to radians, I multiply the degrees by pi over 180. So it's pretty straightforward. If I want to change this to radians, I multiply 125 times pi over 180. Okay, now when we use trigonometry and we look at these angles, we don't actually divide these and find a decimal. What we do is we simplify this down as far as we can go. So what number goes in, how can we simplify this fraction? Well, what we can do is divide. I know we can divide 5 in here. 5 goes into 125 25 times, and 5 goes into 180 36 times. So that's as far down as it's going to simplify. So we just simplify that fraction, and that's equivalent to 125 degrees. Okay. Now, if I was to go the other way, well, maybe we'll do one more example. Let's try 75 degrees. And I want to convert that to radians. So if I convert that to radians, I just take 75 times pi over 180, and then I simplify this fraction down. So again, 5 goes into 75 15 times, and 5 goes into 180 36 times. Okay, looks like I can go further because 3 goes into each of those. So 3 goes into 15 5 times, 3 goes into 36 13 times, so it'll be 5 pi over 13. Okay, so that's how I'm converting degrees to radians. Radians to degrees is even easier. So let's just say I wanted to convert the angle pi over 4 into degrees. Well, I use the fact that pi is equivalent to 180, and I just substitute 180 in for pi and divide it out. 180 divided by 4 is 45 degrees. Okay. Let's do a different one, like 3 pi over 4. So I just go 3 times 180 divided by 4, and I would get 135, I believe. 3 times 180 divided by 4, you can check that. You get 135 degrees. So that's how we convert from radians to degrees. We could also use this formula here by solving for d in this equation. You can multiply 180 times the radians and divide it by pi. But it's a lot easier if I have pi in my radian measure. I just substitute 180 in for pi and do the math there. Okay, so that's how we convert degrees to radians, radians to degrees. Now we know what radians are. A radian is the distance around a unit circle. Okay, last thing in this section, we got a little time for it, is how do you find the arc length and area of a sector? So what a sector is, a sector of a circle is kind of like a piece of the pie right here. Okay, so the arc length is the length of the crust, and the area is the area of the little section there of the pie or pizza or whatever. Okay, so the way we find the area of a sector, we know the formula for area of a circle is pi r squared. all we do is multiply the area of a circle times the ratio of whatever the central angle is, which is that little angle, over 360. Because it's really a ratio of the whole circle. Okay, so that's the formula if we're in degrees here. Okay, the arc length relates to circumference. The whole distance around a circle is 2 pi r, so we just multiply that by the ratio of the central angle over 360. Okay, if we're in radians, we do the same thing. The only difference is we multiply pi r squared times the radian measure over 2 pi, because 2 pi is equivalent to 360 degrees, distance around that circle. Okay, now when I do that though, this formula actually simplifies. The pi's cancel, so I end up getting this formula. Okay, and that's in your book as well. So this sometimes is harder to remember. This one seems kind of like it makes sense. You take the area of a circle, multiply it by the angle over 360, or you take the circumference and multiply it by the angle over 360. This one is something you have to memorize a little bit. Okay, arc length, same thing. Angle over 2 pi times 2 pi r, the 2 pi's cancel, and you can simply get the answer by taking the central angle times the radius. This is the radius here of the circle. Okay. Alternatively, we could convert this the radian measure to degrees and use these formulas if you want. It actually gives you a cleaner answer that doesn't have pi in it. Okay, so let's just do last two examples here. Find the area and arc length. So let's start with this first one. The area would be the angle 50 over 360 times pi radius squared. And now for these, we have to find the area. We want to actually calculate it on our calculator and find the actual decimal answer. So I'm going to do that real quickly. And I get 10.9. And I don't have units here. Let's just say it's feet. So then we have feet squared for area. The arc length is going to be the angle over 360 times 2 pi times the radius, 2 pi r. Okay, so let's see. So we're going to get I get 4.36 for that one. Feet. Okay. B. Now this one, the angle is pi over 5. It's in radians. So my area, then I'm going to use this formula here. 1/2 times pi over 5 times the radius squared. So this is going to be 25 divided by 5 is 5 times 1/2 is 5 over 2. So let's see here. So on the top I'm going to have pi times 25 over 10. So it's actually 5 goes in there 5 and 5 goes in there 2. So it'll be 5 pi over 2 is the actual area. Okay, but we could multiply that out and actually multiply by the pi, which is 3, multiply by the 3.14. Whoops. And I end up getting 7.85. Okay, and the arc length would be this formula here, which would be pi over 5 times the radius, which is 3, would be 3 pi over 5. I goofed up this last one, didn't I? I used 5 for the radius instead of 3. So, but you get the idea of how you got to do that. So 3 times pi divided by 5 is 1.88. Pencil's running out of lead. Running out of lead. 1.88 for the length there. Okay. Alternatively, we could have actually just substituted and converted this. This is 180 over 5. And that would be what, 35 degrees. And then I could use these formulas if they're easier for you. But either way, that's how we find the arc length and area of a sector. Okay, so in this section, we learned how to draw general angles. We learned what radian measure is and how to convert. And we also learned how to find the arc length and area of a sector. So there's a lot of things in here to look at. That's it for section 13.2.